is having element 1, 2, 3, 4, 5, 6. Define a relation R from A to A by R. Okay, R is given in set builder form, set of all ordered pair xy such that y is equals to x plus 1. Depict the relation by using arrow diagram. So yeah, we represented it by using arrow diagram. Since the relation is defined from A to A, so first we'll be taking A, here also we'll be taking A. A have 1, 2, 3, 4, 5, 6, and the other A also will contain 1, 2, 3, 4, 5, 6. Now arrow we need to draw according to the given condition that we have to take. Just a moment. Yeah, so we have already done this question and we have represented the arrow diagram. Here the arrow diagram will look like this. We have to take all ordered pair xy such that y is equals to x plus 1. So if we will take x as a 1, y will be 1 plus 1, that is 2, right? If we have already, we have taken x as a 2 and we will get y as a 3. If we will take x as a 3, y will be 4. If we will take x as a 4, y will be 5. And if we will take x as a 5, y will be 6. Now we cannot take x as a 6. Why? Because we cannot say x is 6 and y is 7, which is not even present in the other set, right? The second set. Yes or no?
Yes, sir.
Okay, so we have already discussed this question. Now the definition of function says to identify the function, there is two rule which is really important. The first rule says that each and every element in the first set, each and every element must have its image in the second set. Okay, so in the first set, elements are 1, 2, 3, 4, 5, 6. All are having its image. 1 is having the image, 2 is having the image, 3 is having the image, 4 is having the image, 5, 2 is having the image. But can you see 6 is not having the image in the second set?
Yes, sir.
Okay, so rule number 1, each element from first set must have its image in second set. If that is the case, then we will say that, okay, the rule number 1 is verified. Now we will be checking the second rule. Only 2 rules are there. Just 2 rules. If this 2 rule is matching, then we will say the relation is a function. If this 2 rule is not matching, then we will say the relation is not a function. So the rule number 1, each and every element must have its image. Okay, each and every element from the first set must have its image in the second set. If your set is defined as a which has 6 element 1, 2, 3, 4, 5, 6, then all must have its image in the second set. If that is verified, if that is getting fulfilled, then we will be checking the second rule. Okay, now the second rule says that, can you see this figure, this arrow diagram?
Yes, sir.
Okay, the second rule says that from the first set, each and every element must have its unique image. Okay, unique image. Here we are having 9 and 9 is input. We can say the first element is 9 and the next element is 3. We can also see the first element is 9 and the next element is -3. Okay, so one element cannot generate two output. If that is the case, then it is not a function. Okay, each and every element must have its unique image. Each element from first set must have its unique image. Okay, that's this is the rule number 2. The first rule says that each and every element must have its image. All the element must have its image in the second set. And the second rule says that the images has to be unique. Unique means what? Unique means you are having the ordered pair 9 comma 3, you are having the ordered pair 9 comma minus 3, you are having the ordered pair 4 comma 2, you are having the ordered pair 4 comma minus 2, you are having the ordered pair 25 comma 5, you are having the ordered pair 25 comma minus 5. Okay, here two distinct ordered pair, two distinct ordered pair. Distinct means different ordered pair. This ordered pair and this ordered pair, these two are completely different. Completely different. Okay, two distinct ordered pair cannot have the same first element. It must not have the same first element. If you are saying that the ordered pairs are different and then also the first element is matching, so this is not allowed in a function. Again, listen to me carefully. I am saying rule number 1 says that each and every element, even if here 10 elements are there, 5 elements are there, all will have its image. All will have its image. If any one of them doesn't have its image, then it is not a function. So all must have its image. And rule number 2 says that if you are, you can understand it like this, that suppose, let me give you one example. First, if we are having mapping diagram like this, if A is there, B is there, C is there, D is there, E is there, here 1 2 3 4 5 is there. So A is related. A is having its image as a 2, B is having its image as a 1, C is having its image as a 3, D is having the image as a 5, and E is having the image as a 4. If this is the case, okay, all A, B, C, D, E, each and every element from the first set has its image. Rule number 1 verified. Rule number 2 says that each and every element must have its unique image. Unique means A is having the image just one. Okay. Then B is having the image just two. Just two. Unique. Okay. That means B, comma, any other element is not there. Okay, it has to be unique. C is having the image as a 3, D is having the image as a 4, and E is having the image as a 5. If that is the case, then you can say, yeah, this is a function. Okay, and also this is also allowed. Okay, suppose we are having mapping diagram like this. uh, Suppose here only two elements in the first set. First element is switch, next is remote. Okay, when we are pressing the switch, fan is on. Okay, we have one more option. When we are pressing the remote, fan is on. So this is allowed in function. This is allowed in function. We will say that switch comma fan, this is one ordered pair, and remote comma fan, this is another ordered pair. This is okay in a function. Okay, first element should not match. Can you see the first what is not allowed? Let me show you here only what is not allowed then. if you are having just a moment, I am rubbing this one. If you are having 3, 4, 5, okay, 3 is related to 9, 3 is related to -9, maybe like that. Okay, 4 is related to 16, 4 is related to -16, like that. If this is the case, you can see, okay, if one input is generating two outputs. If that is the case, then it is not a function. Making sense?
Yes, ma'am.
Yes, ma'am.
Okay, so this is a function. This is a function. Okay, it is completely allowed. You can, whenever you will get confused, you can recall it this way, that when we are pressing the switch, one of the switch, just one of the switch, okay, and fan is on, fan is on, AC on, okay, light on. Have you seen such a structure anytime, anywhere? Have you? Okay, just we are pressing one button, one switch, not the main switch. Okay, just one press you are doing, and fan, AC, light, everything on. Does it works like that? No, right? So this is not allowed in function as well. So what is allowed? This is allowed, that when you are giving one input and the output is coming, when you are giving another input, maybe the same output is coming, that is okay. Making sense?
Yes, ma'am. Previously, you showed the 1 to 6 first rule, right?
Yeah,
Can you show that again?
just a moment. This one.
Before that, ma'am.
This one.
Yes, ma'am.
Yeah, here 9, you can see 9 with 3 is
From
there.
1 to 6.
Yeah,
Before
but
this.
I said that this is not a function, right?
Yes, sir.
Yeah. So when we will solve few more questions, we will generate clarity. Let's work with the question.
Okay.
Can I scroll down?
Yes, ma'am.
Yeah. Suppose the question is a relation R consisted of so many ordered pair. Here 2, 1 is there. Okay, 3, 1 is there. 4, 2. Okay, either you try understanding from here or you draw the mapping arrow diagram like this. Okay, 2 is there, 3 is there, 4 is there. And just a moment, let me see the set is defined or not. No set is defined. Just like that, the question is there, identify the given relation is a function or not. Okay, so we are just trying to check, is this relation, is it a function or not? Can we call it function? So 2 is, image of 2 is 1. Image of 3, that is also 1. Image of 4, that is 2. So first rule, first condition says that each and every element from the first set must have its image. 2 is having image, great. 3 is having image, great. 4 is having the image, great. Rule number 1 verified. Rule number 2 says each and every element from the first set must have its unique image. So image of 2 is 1 and 3 is saying my image is also 1. So the image is not unique. Can you see?
Yes, ma'am.
Okay, each and every element must have its unique image. Okay, if this elements are different, here 2 and 3, these two elements are completely different, then their image must not match. Okay, each and every element from the first set must have its unique image. The image of 2 is 1 and the image of 3 is 1. Okay, hence the image is not unique. Rule number 2 is not getting validated over here. Hence this is a relation but not a function. Making sense?
Yes.
Let's see few more questions. And one more definition is there. Okay, if you are having two distinct ordered pair, 2 comma 1 and 3 comma 1, these two are two different ordered pair, right?
Yes, ma'am.
Wait, just a moment now. I was explaining you that two distinct ordered pair cannot have the same first element. Okay, and here the first element was not same. Wait, this is allowed. Okay, this is allowed. Two distinct ordered pair cannot have the same first element. I was thinking about another example and was explaining this one. Two distinct ordered pair. Can you see 2 comma 1 is there and 3 comma 1 is there?
Yes, ma'am.
You are pressing the switch, light is on. When you are pressing the maybe remote button and the light is on, this is completely fine. Yes or no?
Yes, ma'am.
Okay, this is completely fine. I thought we'll be taking such example where it will not be function. Okay, so yeah, let's start. The rule number 1 says each and every element from the first set must have its image in the second set. Rule number 1 verified. Rule number 2 says each and every element must have its unique image. This unique image, okay, sometimes can be confusing. You can understand it this way, that if you are having two distinct ordered pair, 2 comma 1 and 3 comma 1, these two are completely two different coordinates or two different ordered pair. Yes or no?
Yes, ma'am.
Okay, it must not have the same first element. First element is same? No. Then it is a function. Okay, the definition of function says two distinct ordered pair cannot have the same first element. Okay, so these are the only two rule. Let's do few more question and then we will develop clarity for this one. Is it clear to all of you, Manvi, Mariam and Nabila?
Yes, ma'am.
Okay,
Yes.
it's a function.
Yes,
It's a
ma'am.
function. Let's take few more example. So we are having the arrow diagram. Let's draw the arrow diagram. Either you can understand from here itself or you can draw the arrow diagram. Let's draw the arrow diagram. 2 is there. Okay. Then again 2 is there. Then 3 is there. 4 is there. Okay. And here 2, 4, 3, 4. So basically 2 is there, 3 is there, 4 is there. Okay. Now let's connect. 2 is, image of 2 is 2. Image of 2 is 4. Okay, image of 3 is 3 and image of 4 is 4. Now we just have to identify whether it is a function or not. So rule number 1, each and every element in the first set must have its image in the second set. So 2 is having the image, 3 is having the image, 4 is having the image. Great. Rule number 1 verified. Okay, now rule number 2. Rule number 2 says if you are having two distinct ordered pair, here the ordered pair clearly mentioned. This is ordered pair, this is ordered pair, this is ordered pair, this is ordered pair. Two distinct ordered pair. Okay, so the first two we can compare at first. 2, 2 is there, 2, 4 is there. Is this two are different ordered pair, different coordinate? Of course, these two are completely different from each other. Yes or no?
Yes, ma'am.
cannot have the same first element. Two distinct ordered pair cannot have the same first element. Can you see the first element over here and the first element over here?
Yes, ma'am.
This is not a function. Again, one input cannot generate two outputs. Okay, this is not allowed in a function. Is it making sense?
Yes, ma'am.
What is allowed then? This is allowed, that two input can generate the same output. Okay, one is attached with A and two is also giving the image as a. This is allowed, but this is not allowed. So what is allowed? This way, if the arrow is coming, okay, this is not allowed. And if the arrow is coming this way, then this is okay. Making sense?
Yes, ma'am.
Let's take few more example. Here the relation R is defined as 1 with 2, 2 with 3, 3 with 4, 4 with 5. Okay, let's see whether it is a function or not. Okay, so here no other set is defined so that we can check that each and every element has its image or not. Rule number 1 says from the first set, each and every element must have its image. Each and every element must have its image. That is rule number 1. So for this type of question, when the relation set is given in raster form, we don't have any set over here. Okay, so we can say, yeah, okay, one one is there, two is there, three is there, okay, four is there, five is there, then six is there. Only these are the element, and yeah, all are having its image in the second set. So rule number 1, we don't even have to check in such question. Making sense? Getting it? Okay, rule number 2, we will be checking minutely. So one is related, connected with one, it's having its image as a 2, 2 is having the image as a 3, 3 is having the image as a 4, 4 is having the image as a 5, 5 is having the image as a 6, and 6 is having the image as a 7. Okay, now we just need to check, no two distinct ordered pair cannot have the same first element. Anywhere first element is matching, so many ordered pair we are having over here, so many ordered pair. Anywhere the first element is matching, no. So we don't have to get confused. It's a function. It is a function. Yes or no? Is it clear? One
Yes.
more definition says that each and every element from the first set has its unique image. So when you are giving the input 1, output is 2. When you are giving the input as a 2, output is 3. So unique image, it's there. It's a function. Clear?
Yes.
Just a moment. Let me take few more examples. We are having the relation. Just a second. So yeah, we are having the relation defined like this. R is we are having the set xy can be taken from 1, 2, 3, 4. This set. Okay. And relation 1 says that set of all ordered pair y, which we did just now. Okay. But it was quite different. Here, this y is equals to x plus 1 is same. But I think the original set is different. We will be checking whether it's a function or not. Another relation is given like this. Set of all ordered pair xy such that x plus y is bigger than 4. Third relation says that set of all ordered pair xy such that y is smaller than x. And one more we are having set of all ordered pair xy such that x plus y is equals to 5. Let's see these relations are functions or not. Okay. So here the set is defined. We have to take x and y from this set. So our x 1, 2, 3, 4. Y 1, 2, 3, 4. According to first relation, y is equals to x plus 1, which we have done just now. Okay. When x is 1, y will be 2, right? Right? Yes or no? When x is 2, y is 3. When x is 3, y is 4. And when x is 4, we cannot take. Is it a function? Yes or no? Please tell me. The first relation, is it a function? Is it a function? This one, this one. Is it a
No,
function?
no, ma'am.
Okay, it's not a function. Why? Because rule number 1 says each and every element from the first set must have its image. See, 1 has the image 2, 2 has the image 3, 3 has the image 4, but 4 doesn't have any image. Can you see? So rule number 1 is not getting verified. It is not a function. We are not going to check rule number 2. Making sense?
Yes, ma'am.
Okay, next one. We have to take set of all ordered pair xy such that x plus y is bigger than 4. Tell me, 1. Can I connect 1 with any element? Image of 1 will be, image of 1 will be, according to this one, if we will take x as a 1, then y has to be
4.
4. Okay, so image of 1 is 4. Yes or no? We have to take all such ordered pair xy where x plus y is bigger than 4. Yes or no? So 1 comma 4.
Yes, ma'am.
Okay, 2 comma 2 with,
3.
okay, 2 with 1, no. 2 with 2, no. 2 with 3. We can take 2 with 3. And 2 with any other element?
Not allowed.
We can also take 2 with 4. Is it so?
Yes.
Okay, recall the Cartesian product. We were taking all the possibility. Okay, 1 with
Yes.
1, 1 with 2, 1 with 3, 1 with 4. 2 with 1, 2 with 2, 2 with 3, 2 with 4. 3 with 1, 3 with 2, 3 with 3, 3 with 4. And relation came from, relation is nothing but just a subset of Cartesian product. So even though we are getting 2 comma 4 again, we are not surprised at all, are we? Okay.
No.
So here we are getting the set. Let me write it. 1 with 4, just that. 2 with 1, no. 2 with 2, no. 2 with 3, yeah. 2 with 4, yeah. At first, we must develop clarity with the relation. What are the ordered pairs we are having? Then we will think about the function. Yes or no?
Yes, ma'am.
Okay. Then 3 with 1? No. 3 with 2? Yeah. 3 with 3? Yes. 3 with 4? Of course. Then 4 with 1? No. Yeah. 4 with 1 we can take because the summation has to be bigger than 4. So 4 with 1 is fine. 4 with 2? Yeah. 4 with 3? Yes. 4 with 4? Yeah. Can you see? Set of all possible ordered pair which is fulfilling the condition x plus y bigger than 4. Yes or no?
Yes.
Okay. Now look at your ordered pairs. The first condition, each and every element must have its image from the first set. The set is this one. XY belong to 1 2 3 4. There is a set defined initially in the question that we are having a original set, okay, which have 1 2 3 4. So all this 1 2 3 4 must have its image. 1 has the image, yeah. 2 has the image, yeah. 3 has the image, yeah. 4 has the image, yes. So for function, the first condition is getting fulfilled. Yes or no?
Yes, ma'am.
The second condition,
No, ma'am.
that first, if you are matching the ordered pair, okay, arrow diagram you can check, or maybe ordered pair you can check. So you are already having all the ordered pair, just match the ordered pair. Can you see two ordered pair which has the same first element? Two ordered pair which has the same first element. Let's focus. Can you see 2 comma 3 and 2 comma 4? Two
Yes, ma'am.
ordered pair, two different ordered pair which has the same first element. 2 2. This is not allowed in a function. Making sense?
Yes, ma'am.
Okay. Similarly, here also you can see 3 comma 2, 3 comma 3, 3 comma 4. Three different ordered pairs we are having, 3 2 3 3 3 4, but in all these three ordered pair, the first element is matching. First element should not match, second can match. Okay, in this three ordered pair, if the second element would match, then we can declare, yeah, it's a function. But if the first element is matching 3 3 3, then we will take a pause and we will say that rule number 2 is not getting verified. Why? Because the same 3 is giving the image as a 2, the same 3 is giving the image as a 3, and the same 3 is giving the image as a 4. So one element is giving so many images that is not possible in a function. Is it making sense?
Yes, ma'am.
Okay. So this is a relation, but it's not a function. Next one. Third, relation number 3. Okay. Here the original set, again I am helping you recalling, was consisted of 1 2 3 4. Okay. Yeah, just 1 2 3 4. So the third relation, let's write all the ordered pair for this one. R, we will be taking, okay, all ordered pair x comma y, where y is smaller than x. Y is smaller than x. Okay, your original set is 1 2 3 4. From here only you are supposed to take your x, and from here only you are supposed to take your y. Okay, so we have to take all those ordered pair where y is smaller than x. If we will take x as a 1, y is smaller than x. We don't have any number that is smaller than 1. Yes or no?
Yes, ma'am.
So we cannot take x as a 1. X as a 2, yeah. Y has to be smaller than x. That means y can be taken as 1. Okay. X as a 2 and then any other y? No. Then x as a 3, y can be taken as, please tell me.
1 and
Or
2.
maybe 2. Okay. Then x as a 3, y can be maybe 1, maybe 2. Okay, we have written. 3, 4. Y can be 1, Y can be 2, Y can be 3, right?
Yes, ma'am.
That's it. Okay. Can we take X as a 1 we have not taken, 2 we have taken, 3 we have taken, 4 we have taken. Yeah, we have taken everything. Is it clear? The relation is clear.
Yes.
So first, patiently, even though in our minds, our subconscious mind will say that, okay, we'll start thinking about the function. Is it a function? It's not a function. Don't take this ordered pair. This ordered pair is not allowed over here and all. Please take a pause and just write the relation first. Okay, now we will verify is it a function or not. So the first rule says that each and every element from the given set, this relation is defined from this given set. Okay, this set 1 2 3 4 to this set. Okay, so each and every element must have its image. You can see in your relation one doesn't have any image, one doesn't have any image. Can you see?
Yes, ma'am.
Okay, so of course it is not a function. Do we need to check the rule number 2? Not at all. If the first rule is not matching, then why we will check the second one? Clear?
Yes, ma'am.
Okay, this one, let's do it quickly. R will consist of all those ordered pair where x plus y is 5. So I can take x as a 1 and y as a 4. X plus y is 5. Okay, we can take x as a 2 and y as a 3. X plus y is 5. We can take x as a 3 and y as a 2. X plus y is 5, right?
Yes, ma'am.
We can take x as a 4 and y as a 1. X plus y is 5. And we are done. Now we will check whether it is a function or not. So each and every element must have its image. 1 has the image. Okay, 2 has the image. 3 has the image. And 4 has the image. Yeah, the first rule is getting validated. Now the second rule. Okay, without drawing the arrow diagram. Just a minute. Now the rule number 2. Okay, no two different ordered pair can have the first element same. Okay, 1 comma 4 is there, 2 comma 3 first element not same, 3 comma 2 first element is not same, 4 comma 1 first element is not same. So in our all the ordered pair we are having in front of our eye, and we can see, okay, nowhere we can see the first element same, right?
Yes, ma'am.
Hence it's a function. Both the condition getting validated, it is a function. Is it clear?
Yes, ma'am.
Let n be the set of natural number and, okay, I needed to explain the domain as well. I'm coming to that. Let's check it. Let n be the set of natural number and relation r define on n. Define on n means your first set is natural number, set of natural number, and the second set is also the set of natural number. It is define on n means this is natural number collection and this is also natural number set. Okay, such that set of all ordered pair xy such that y is equals to 2x. Okay, y is equals to 2x. So natural number, we understand the first set will start from 1 2 3 4 5 6 7, just like that. Okay, for few number we will check and we will understand the pattern and then we will clarify whether it is a function or not. For the next natural number set we will be having 1 2 3 4 5 6, just like that, and dot dot dot. Okay, now here it says that we have to take all those ordered pair where y is equals to 2x. So if we are taking x as a 1, y will be
2.
2. If we are taking x as a 2, y will be 4. If we are taking x as a 3, y will be 3 2 times 6. If we are taking x as a 4, y will be 8. If we are taking x as a 5, y will be 10. If we are taking x as a 6, y will be 6 2 times 12. If we are taking x as a 7, y will be 14. Now we need to check whether it is a function or not. Rule number 1. Each and every element from the first set must have its image in the second set. So we can see whatever you take as a 1, you will be getting that y in the other set. Yes or no?
Yes, ma'am.
Okay, we have taken 1, we are getting the image 2, 3, 4, 5, 6, 7, 8. Even though we can just keep on going and keep on going and keep on going, we will still be keep on getting the images as natural number. All of sudden decimal number will not start coming. Okay, natural number will come as an image always. So each and every element in the first set has its image in the second set. Can we say it confidently?
Yes, ma'am.
Even though we are having the set of natural number as an infinite set where we are not able to see all the ordered pair, but we are confident enough that yeah, each and every element in the first set will have its image.
Yes,
This
ma'am.
thing should not confuse you that in the second element there are few element which is not attached with the arrow. That is okay. In the first set, we are saying from the very beginning. In the first set, each and every element must be attached with the arrow. That is happening over here. So rule number 1 is getting verified, right?
Yes, ma'am.
Okay, now we know that one element from the first set cannot have so many different images, like image of 1 is 2, image of 1 is 3, image of 1 is 5, or just even though more than one is also not acceptable, right?
Yes, ma'am.
So we can see 1 is generating 2, unique. 2 is generating 4, completely unique. 3 is generating 6, 4 is generating 8, 5 is generating 10, 7 is generating 14. So first element, whatever ordered pair we will write 1 comma 2, 2 comma 4, 4 comma 6, wait, 3 comma 6, 4 comma 8, okay, 5 comma 10, 6 comma 12, 7 comma 14. We can clearly see that no two ordered pair has the same first element. Okay, so
Yes.
this relation is a function. Are you getting it?
Yes, ma'am.
Okay, so always all the ordered pair will not be in front of our eye, but we need to understand it this way so that even though we are having infinite set, we can still see the pattern, figure it out whether it is a function or not. Yes, Manvi, Mariam, Neha, is it making sense to all of you?
Yes.
Just a moment. Let me take few more examples. One more thing I must explain over here, since in each and every question we are saying that whatever is the first set, okay, each and every element from the first set must have its image in the second set. Okay, this condition must be fulfilled. This is the rule number 1, and rule number 2 we are having in hand. So from the rule number 1, can we declare that the first set completely will be the domain set always? When we are saying a relation is a function, that means the first set completely is the domain. Yes or no?
Yes.
Okay, recall last class I was telling you domain means in a relation you will be having few ordered pair, maybe 1 with 2, maybe 2 with 4, maybe 3 with 6. This way you are having the ordered pair, and domain is the set of all first element. That means domain means just the first element, 1, 2, 3, just that collection is called the domain set or the domain. And in function also we are having the same domain concept. Okay, same domain, range and codomain exist in a function as well. Okay, while checking whether the given relation is a function or not, we also be talking about what is the domain, what is the range, what is the codomain. So when you will find a relation is a function, then domain will be completely the first set, completely first set. Why? Because in first set each and every element is connected with the arrow, is having the image, is generating the output. That's why when a relation is a function, the complete first set is a domain, just like this one, the question which we did just now, the previous one. See carefully. Let n be the set of natural number. Okay, relation is defined set of all ordered pair xy such that y is equals to 2x. Okay, we have taken few natural number in the first set, few natural number. Okay, till 7 we have checked. One is generating the output, 2 is generating output. Okay, 3 is giving the image, 4 is giving the image, 5 is giving the image, 6 is giving the image, 7 image, 8 will give, 9 will give, just like that all the natural number will give the image. So can I say domain will be the set of natural number?
Yes, ma'am.
Is it making sense to all of you? No?
Yes,
Any
ma'am.
who is not getting? Mariam, Manvi, Neha, are you getting?
Yes, ma'am. Yes, ma'am.
The domain will be the set of natural number, the first set completely, and the first set is what? Natural number set. Just a second. Yeah. And if I will ask what is the range, what is the range in this particular question, what is the, okay, let's think about first codomain. Codomain means the completely second set, right? Complete second set. Yes or no?
Yes, ma'am.
So codomain is also the set of natural number, right?
Yes, ma'am.
Domain is the set of natural number. Codomain is also the set of natural number. And what is range? So range is just the set of all those element in the second set which has its pre-image. All those element in the second set which has its pre-image. You can clearly see 2 has the pre-image in the second set, 4 has the pre-image in the second set, 6 has the pre-image in the second set, 8 has the pre-image in the second set. Are you able to notice the pattern? 2 has
Yes.
the pre-image, 4 has the pre-image, 6 has the pre-image, 8 has the pre-image, 10 has the pre-image, 12 has the pre-image. So range will be set of all. Can I say set of all even natural number?
Yes, ma'am.
Making sense? All those numbers which are even. We are noticing a pattern in the second set. Okay, range means all those element in the second set which has its pre-image. The moment we are just noticing the pre-image carefully, we are finding that 2 has the pre-image, 4 has the pre-image, 6 has, 8 has, 10 has, 12 has, 14 has, okay, 16 has. That means this is nothing but just the set of even number. Yes or no?
Yes, ma'am.
Okay, set of even natural number. That's the range over here. Is it making sense to all of you?
Yes. Yes, ma'am.
Now you understood what is function. Just a second. Now you will find such a question that a function will be given. Just a minute. Suppose a function is given f of x is equals to 2x. Okay, if you are thinking function is what, why we are writing like this relation, till relation it was clear that relation is what, relation is a uh, just nothing but just a set. We were writing it in roster form, we were writing it in set builder form. Now all of sudden we are saying a special type of relation is a function. And what are the those relation which is just fulfilling those two rule? Okay, if those two rule is getting fulfilled, then we were calling it a function. Now after that discussion, how are all of sudden we are writing f of x is equals to 2x and we are calling it a function? Why we are doing so? Isn't it a set? So yes, a function is a set. Okay, a function is a set. Just like relation, a function is a set of ordered pairs. But sometimes it is not possible for us. When the function is defined from a real number r to real number r, then it is not possible for us to write all the ordered pair or maybe the first few ordered pair. It is not possible because real number is okay infinite. So we are not able to represent it exactly by using the ordered pair, ordered pair, ordered pair, ordered pair. Sometimes it is not even possible for us. Why? Because it is connected from one real number to another real number. Okay. For example, a relation R is defined as a set of all ordered pair XY, where X and Y can be taken from the set of real number, and the connection is maybe x is equals to 1/3 of y. Okay, or maybe just a second, let me customize this one. Y is equals to 1/3 of x. Okay, this is how the relation is defined. Now, is it possible for us to write it in this ordered pair format in a given set? Because it's a real number. So which real number you are thinking about at first? The real number is just like a C. And in that C, which number to pick at first, we are not sure about that, right? Real number contain natural number, whole number, integer, okay, rational number, irrational number, everything is there. So which real number to take at first, we are not sure about that. Yes or no?
Yes, ma'am.
That's why we are not able to write it in this format. Okay, just by writing one ordered pair, comma, another ordered pair, comma, another ordered pair, comma, another ordered pair, we are not able to write it in this way. And there comes a rule that, okay, when we are talking about the function, okay, if it is a relation, let's keep it in the set builder form itself. We don't need to write it in roster form. And if we are talking about this as a function, we will be representing it as y is equals to 1/3 x. This y can also be represented as a function f of x, the way you were representing in lower classes polynomial p of x, q of x, h of x. That was nothing but just the representation of the polynomial. Okay, a polynomial containing the variable x is x plus 5, right?
Yes.
Okay, a polynomial containing the variable y is y square plus 22. Similarly, today I am going to tell you that from today onward, we will be writing a function containing the variable x is equals to 1 by 3x. Now, here we will clarify that x can be taken from the set of real number. Now, if we will take any real number as a x, whatever f of x we will generate, okay, that will be the image. Making sense?
Yes, ma'am.
Since it is a set, it is a set. But since we are not able to write it every time in roster form by giving ordered pair, comma, ordered pair, comma, ordered pair, comma, ordered pair, hence we decided that we will be representing it by this type of rule or maybe by this type of equation. And we are going to call it a function. Making sense?
Yes, ma'am.
Okay, so from now onward, we will be having functions written like this, that you have a function where f of x is equals to 2x, or maybe f of x is equals to 1/3 x. Okay, this type of situation will be given. And today I'm just talking about very basic question, that if in case we are having, in case we are having f of x as 1 by x plus 2, it's a function given in the question that you have a function this one, the way previously you used to have given a polynomial this one, here you are having a function this one. Why we are representing function like this, that is clear to you. Now the question will be find f of -1, f of 2, f of pi. So this situation is also not new for you. While dealing with polynomial, you have done this type of question. F of -1 will be at the place of x, we will be dropping 1. Yes or no? -1 I do. Yes or no?
Yes, ma'am.
Okay, and it will be 1 by 2 minus 1. That is 1. Answer is 1. What is it representing? It is representing that the element, okay, you have taken the element -1 and the image it is generating is 1. Getting it?
Yes.
Okay, this is your x, this is your output f of x, which previously you were calling as a y. This time we are representing it with f of x. If x is -1, y is 1, that means f of x is 1. Is it making sense to all of you?
Yes.
Okay, if x is 2, f of x will be 1 by 2 plus 2, that is 1 by 4. So here we can write it this way: if x is 2, f of x is 1 by 4. Why we are writing only few? Okay, only few element in the first set, because again infinite, it can be taken from the set of real number, and we are just having few. Okay, we just have to find f of minus 1, f of 2, and f of pi, and just like the polynomial we will be finding it. Okay, we don't have to go in detail over here. Yeah, this understanding is required, this understanding. Any confusion so far?
No, ma'am.
Now there, if you understood the previous question, will you be able to do this question? If f of x is equals to x minus 1 by x plus 1, given that x should not be minus 1, then show that. Let's do it. Okay, previous one you have already understood. Let's do this one. So we are having a function that is x minus 1 by x plus 1. Here why it is written x not equals to minus 1? Because we understand the denominator cannot be 0, right? Anytime, anywhere in mathematics, the denominator should not be 0. 0 in the denominator not allowed in mathematics. Do you know that?
Yes, ma'am.
Okay, that's why here it is specifically given that x can be any number, any real number, but not minus 1. X can be any real number but not minus 1. Okay, because minus 1 can make our denominator 0 over here. Making sense?
Yes, ma'am.
So our f of x is x minus 1 by x plus 1. A function is given. Then show that this one. Just now you were telling that why I'm teaching you f of 1. You know how to find it. Okay, why I'm showing you how to find f of 2. You know how to do it. Why I'm showing you f of 3 or maybe f of pi. You know how to do it, just like polynomial. So if you know how to do it, if you know how to find f of pi, that is pi minus 1 by pi plus 1, and this is our final answer. Similarly, if we are having f of x, then just drop at the place of x. Okay, the way you have treated pi over there, this pi, how you have substituted, quick, quick, quick. Similarly, this time this is there, whatever is there. Okay, if bird is there, you have to sit, just show me, let me show you. If f of bird is there, bird, then you don't need to ask why bird is written over here. I don't know how to do the calculation with bird. You just need to put bird minus 1 by bird plus 1. Is it making sense?
Yes, ma'am.
Okay, similarly, if f of this is there, okay, don't think that why it is there, just drop it, just like the bird, that is this minus 1 by this plus 1. Is it making sense?
Yes, ma'am.
Okay, now f of x, you know already the original f of x. At the place of f of x, just put the functions value, that is function, this terms. Okay, rational as x minus 1 by x plus 1, this rational algebraic expression, just drop it at the place of f of x. This minus 1 by this plus 1. Is it making sense?
Yes, ma'am.
And we need to simplify it, and we need to simplify to check whatever is given for f of x. Is that true? Is it making sense? Let's check it. But till here, is it getting clear to all of you?
Yes, ma'am.
Yes.
Okay, so in numerator we'll be taking the LCM as a x plus 1. Numerator will be x minus 1 minus bracket x plus 1. Okay, in denominator we will do the simplification. This type of simplification is not new for you. Okay, trigonometry chapter in class 10 you have done. Okay, and you were dealing with such simplification over there, maybe with the numbers. So yeah, x plus 1, here we are having x minus 1 plus x plus 1. Okay, here x plus 1 will cancel out each other, and we'll be having x minus 1 minus x minus 1. Here we'll be having x minus 1 plus x plus 1. 1, 1 gone, x gone. We are having minus 2 by x plus x, 2x. Minus 1 by x. Can you see that? This is what we wanted to
Yes,
prove.
ma'am.
This is what we wanted to prove. Yes or no?
Yes, ma'am.
Okay, why then provided x not 0, that is given just for the clarity that the denominator will not be 0. Okay, clear so far? Any confusion to anyone?
No, ma'am.
Now you will also see piecewise defined function. Okay, you will also see in this chapter piecewise defined function. Piecewise defined function, for example, will look like this. Just for example, f of x is equals to, this way your function will be there. Okay, and it will be defined in a pieces. In pieces it will be defined just like this, that when x is bigger than 1, then f of x will be x minus 2. Okay, and when x is smaller than, wait, just like this. Okay, this is a example of piecewise defined function. Piecewise defined function is what? Piecewise defined function is, okay, this is till now you have seen f of x is equals to 2x, or maybe f of x is equals to x minus 1 by x plus 1. Okay, for whatever, for all the real number. Okay, x can be taken as any real number. Yeah, minus 1 was not allowed. Or maybe f of x is equals to x square plus 5. Okay, till now you have seen functions like this. Okay, you take any real number as a x, and accordingly you will keep on getting the output y. That means f of x you will keep on getting. Here the this function is piecewise defined, that if you are if you will take x is smaller than 1, I let me show you in the coordinate axis, it will make more clarity. And let me make it more simple so that we don't even have to calculate. Okay, let's see. So this function says that when x is bigger than 1, okay, in your coordinate axis, here x, here y. Okay, when x is bigger than 1, somewhere 1 is there. When x is bigger than 1, then your output will be 0. F of x will be 0. Okay, when x is 2, f of x is 0. This is the point. Okay, when x is 3, f of x is 0. When x is 4, f of x is 0. When x is 5, f of x is 0. Okay, and when x is smaller than or equals to 1, f of x is minus 1. So when x we are taking is smaller than 1, maybe this one, maybe this one, or maybe 1 itself. Then f of x is generating the output as a -1. So this point, this point, this point, okay, this way you take any x, it's just like the coordinate. When you have taken x as a, let's say 0.5, then f of x is -1. When you have taken x as a 0, f of x is -1. When you have taken x as a -2, f of x is -1. When you have taken x as a -3, f of x is -1. When you have taken x as a -5, f of x is -1. And if you will keep on locating all those points, you will be getting something graph like this. Okay, broken graph, pieces of the graph. One of the line will go like this, and the previous one will give you another line, which will just go through these points. Making sense?
Yes, ma'am.
This is the graph for this piecewise defined function. Piecewise defined function we are having. Okay, f of x is, when x is bigger than 1, f of x, y is 0. Okay, when x is bigger than 1, y is 0. So when you have taken x as a 2, y is 0. X as a 3, y is 0. X as a 4, y is 0. X as a 5, y is 0. X as a 6, y is 0. Accordingly, we have located the point, and for the, when x is smaller or equals to 1, y is -1. And accordingly, we have located the point. This is how the graph looks like. So are you understanding that this is nothing but just the function defined in pieces? Previously, okay, whatever function we have seen, it used to be given a straightforward manner, but it can be given in pieces as well. Is it making sense?
Yes, ma'am.
So if from real number to another real number, okay, if a function be defined from R to R, that means real set of real number to set of real number, okay, be defined as f of x is equals to 1 minus 1 if x belongs to Q, if x does not belongs to Q. Okay, then find f of 1 by 2, f of pi, and f of root 2. Let's do it. For this one only, I was explaining you that what is piecewise defined function. Please see carefully. Our function is defined from real number to real number and defined as, no worries, it is defined in a piecewise manner. So when you will take x as a rational number, q means rational number. In first chapter, if you I have explained that set of rational number can be represented by capital letter Q. So if your x is a rational number, output will be 1. Any rational number, output will be 1. So if you will take f of 1 by 2, if you will take 1 by 2, is it a rational number? Is it a rational number? Is it a rational number?
Yes,
1
ma'am.
by 2? Yeah. Any number which is in the form of p by q. Okay. Where p and q are an integer, but q not equals to 0. Those numbers are called rational number, right?
Yes, ma'am.
So 1 by 2 is a rational number. Okay, when you will take x as a rational number q, then the output or the image will be 1. Making sense?
Yes, ma'am.
You take any other rational number, output will be 1. You take an other rational number, output will be 1. If you are thinking this is not a function, it is a function. Okay, first element is not same. Can you see? Making sense?
Yes, ma'am.
Okay, so the value for f of 1 by 2 will be, since 1 by 2 is a rational number, output will be 1. Clear?
Yes, ma'am.
f of pi. This pi is rational or irrational?
Mhm.
Pi is irrational, right? Okay. Now here in the piecewise defined function, clearly mentioned if your x is a rational number, result will be 1. If your x is not a rational number, result will be -1. So f of pi will be -1. Is it making sense? Will you get
Yes.
confused in such MCQ question? No, right?
Yes.
Okay, what about f of root 2? So we will think root 2 is rational or irrational?
Irrational.
Irrational. So if our x is not a rational number, then the output will be -1. From where are we saying this thing? From the piecewise defined function. Can you see that?